messed that up.
Okay.
I messed it up pretty good. So, all right, you guys. So here's my version of this analysis of a scatter plot. I use my own scatter plot, so I didn't have to make one. Here's my data. Here's my scatter plot. It's already made for me. The blue pen stuff comes later, so we'll get to it. The first three things are R squared and the line least squares regression line. Those you have to plug these into your lists to make it happen. So stat, edit, and you put them in your lists. Then you can second quit, stat, calc, go down to linreg, and hit enter through everything, and you'll get those values. The A and B go into the y equals a plus bx. And then we have our interpretations. So that's a pretty high R value and it's positive, so I know that temperature and ice cream sales are strongly linear and positively correlated. Please use context. I talked about temperature and ice cream sales there. You should be talking about whatever your scatter plot's talking about. So I turned that into 91.68%. And the R squared means 91.68% of the variation in Y is explained by its linear relationship with X. Temperature was my X, sales are my Y. So 90-something% of the sales are because of the temperature. The rest is because of other stuff. So here's my line that I got. Defining my variables. X and Y are variables, not A and B. X and Y. Temperature and ice cream sales. Interpreting slope and intercept. When the temperature is 0, ice cream sales are at negative $159. Yes, it doesn't really make a ton of sense. It's okay. It's a y-intercept. It's a prediction way outside your data. It shouldn't make sense. Slope. As temperature increases by 1, sales increase by $30. Y-intercept here, slope here. As x goes up by 1, you get 30. When x is 0, negative 159. All right. So, predictions. I said make one that was an interpolation and one that's an extrapolation. I picked 16 and 10. 16 and 10 because they were 16 was inside my data, 10 was outside my data. So 16 was interpolation, 10 was an extrapolation. I also drew it on the graph here as well. So I plugged it in, got out a y, plugged 10 in, got out a y, and then I wrote what they meant. Please write that. At 16 degrees, I predict $321 in sales. 10 degrees, I predict $141 in sales. As for drawing it on the graph, I found out 10, 141, 16, 321. I connected the dots and got a nice graph. I even wrote my two predictions on there with those. You don't have to do that. Okay. What domain is it reasonable to make predictions on for the data set? Well, since extrapolations are unreliable, it also says use those words. Since extrapolations are unreliable, it's reasonable to make predictions between 12 and 25 degrees. That means, look at that, my first point's at 12. Last point's at 25, so I can make predictions between those just fine. That's reliable. Outside of that is unreliable. So you just have to say that somehow. This is how I said it. You can pause it if you want to read it close, but use the words interpolation and extrapolation. Residual, this is the hardest one that you guys have hit now. The point, I picked 2 points, so it says determine the residual for any 2 points. So the first point I picked was this one, the second point I picked was this one, and a residual is y minus y hat. So my y value is the y value from the point, 325. That's the actual y. The y hat is what happens when it's what you predict at the same x value. So I plugged in 16.4 into my prediction. I wrote it a little funny here, but this is me predicting y. This is my actual y, and I subtracted them and got negative 8. Did the same thing over here. That's my actual y. That's me predicting what y is at 17.2. Got a residual of 51. Okay, I drew what a residual plot would look like. This one we're learning today, actually. But if you kind of turn that on its side, you can see what it looks like. This point is below the line. This point's below. That's above, below. So you can kind of see below, below, above, below. It kind of follows your. If your residual is negative, it's going to be below your least squares regression line. You kind of think of that middle x line as your least squares regression line. I know my data is linear because this was consistent variance. There's no curving pattern or any weirdness going on. And my R value was really good. It was like 0.95. So this is for sure linear. I'm good to make predictions on this with least squares regression line, no problem. All right, hopefully that helps. That was a long one, but it's your whole assignment and how to do it all. Do that 4 times and you got it. See you guys.